Hello, everyone. Today, I'm going to present our recent work on revenue maximization for short video advertising. I will start with an introduction to sponsored search auctions, which is the background for short video advertising. Sponsored search auctions emerged 20 years ago when Google began to search their advertisement slots on the search engine pages. Here is a screenshot. If you type in a keyword, for example, personal loan, you will see some green search results. You will also see some links that are sponsored by the advertisers. So every time a search engine user click on those links, the advertisers will have to pay the search engines. And this is the main revenue source of those search engines. So from the advertiser's perspective, each advertiser has a set of interested keywords. For example, if I am a car manufacturer and I want to advertise my product on Google, then I might be just interested in the keywords that are relevant to the car industry and especially to my brand. And each advertiser has also a private value for each of the keywords that they bid for. So this represents the maximum amount of money they are willing to pay if a search engine user clicks on the advertisement link. The advertisers also have a private daily or weekly or monthly budget. This is the maximum amount of money they are willing to spend on the search engine businesses within a day or within a week. So advertisers' objective is to use those budget to buy as many clicks as possible. And this is maximizing the probability that the advertisement is displayed to the audience, and potentially the interested users will buy the product through the links. So from the search engine's perspective, search engines have two jobs. One is to display the green search result, which is usually run by PageRank algorithms. On the other hand side, they also want to make revenue, which is what we talk about, the sponsored search auctions. So they need to select advertisers that are relevant to each user query and decide the order to display them. So they need to match each query with a set of relevant keywords and then display them to maximize the probability that users will click on them. And this is usually run by some auction mechanisms. In other words, search engines have the products of the search engines consist of key slots of the search result, and each slot can generate a certain number of clicks. So what the search engines needs to figure out are how to match advertisers with the slots and how to charge advertisers, and eventually how to maximize revenue. The payment models have been in tradition, there have been three models, but there's one dominant model, which is pay-per-click. So let's start from paper 1,000 impressions. So this is a case where the advertisers needs to pay to the search engines every time the advertisement is displayed for 1,000 times. And pay-per-click means that the advertisers only need to pay to the search engine if a user click on the links. And this is a dominating payment method. And the last one is pay-per-conversion. In this case, the advertisers only need to pay the search engine when a user clicked on the link landed on the advertiser's homepage and bought some product in the end. So this requires some tracking method to track the transaction so that the search engines can correctly charge the advertisers. Okay, so overall, the primary research question in this area is to maximize revenue for search engines, because search engines provide those platforms. They want to make money to run the business. So they need to design online matching algorithms with good competitive ratio. When we talk about competitive ratio, this is in the context of online algorithms, because the user queries come on one by one in an online fashion. Every time a query comes, the search engine needs to decide which advertisement to display and in what order. So they need to compare the revenue of the online algorithm with the offline optimal and maximize this ratio in the worst case. So to introduce the benchmark algorithms, let's start with a very abstract and very simplified version. In this case, all advertisers have the same budget. And once a query comes in and the search engine matches to it, a payment is collected. When a bidder is matched with a query, he pays what he bids. When a bidder's budget is exhausted, he retreats from the market. And there's no click-through rate, no second price, and one-to-one matching. And once it is matched, the payment is collected. Obviously, this is an oversimplified model, but this gives us a clean, a very easy to work on environment. And this is how we designed some algorithms. So let's start with some heuristics. The first heuristic is that to use the greedy algorithm, greedy in this way. So let's say that we have two bidders. They are interested in, the first bidder is interested in Pepsi and Fanta. The second bidder is only interested in Pepsi. And the bidder one's bidding price on Pepsi is slightly higher than bidder two. So if a query Pepsi comes, the search engine will display bidder one's advertisement. Let's say there's only one slot at this moment. And let's say that they all have 100 pounds as budget. And the queries comes in the order of 100 Pepsi followed by 100 Fanta. So in this case, when the 100 Pepsi query comes, because bidder one's bidding price is slightly higher than bidder two's, so the search engine will display bidder one's advertisement, and each time bidder one will spend £1 for the query. So bidder one advertisement will be displayed for 100 times, and then his budget is exhausted, so he is gone. Then 100 Fanta query comes. But in this case, because bidder two is not interested in Fanta, he didn't bid for Fanta, and bidder two is already withdrawn from the market. So these 100 Fanta queries are wasted. There's no advertisement to display. There's no revenue generated for the search engine. So in total, the search engine generated a £100 revenue. And let's figure out the competitive ratio for this case. A better solution for the search engine is that when 100 Pepsi queries come, search engine display bidder two's advertisement. So in this case, search engine generates £99 revenue. And then when 100 Fanta query comes, the as bidder one is still on the market. So search engine can display bidder one's advertisement and collect £100 revenue. So in total, the optimal revenue for the search engine is 199. Obviously, this is given the case that the search engine knows that there will be 100 Pepsi queries followed by 100 Fanta queries. So this is offline optimal revenue. So in this case, the greedy algorithm generate is one half competitive. So a natural question that we ask is that whether or not we can do better. Turns out that there are more intelligent algorithms that can achieve a higher competitive ratio. So this algorithm is called the KP algorithm for the B-matching problem. So I'm not going to run all the example here, but the idea is that because in this case, you can see that bidder one and bidder two, they bid the same price for Pepsi. So when the Pepsi query comes, the search engine could display both advertisements. So each of them will have half of the queries, and search engine can generate £100 revenue as well. And then when the 100 query Fanta query comes, the search engine can display bidder one's advertisement and generate £50 revenue. So in total, the competitive ratio for this case is 3/4. And in the worst case, the competitive ratio for the KP algorithm is 1 minus 1 over E, which is roughly 0.63. Okay, so what we learned here and intuition is that when the search engine decides to display the advertiser's advertisement, the search engine also need to take the remaining budget of these advertisers into consideration. So when the search engines evenly distribute bidder one and bidder two's advertisement here, when the 100 Pepsi queries come, this is in the consideration that both bidders have the same amount of margin and the same amount of budget. So the remaining budget of the two people are the same. By displaying the advertisement evenly, they can the search engine can keep both advertisers on the market. So in future, when some other queries comes, both bidders are still on the market. Okay, so that's what I'm saying. In order to improve the competitive ratio, maybe we should consider both advertisers' bid and the unspent budget. But the difficult thing is to figure out the best trade-off between these two in order to obtain the optimal competitive ratio. So what was presented in a Fox 2005 paper, Edwards and generalized online matching, was that was a factor revealing LP algorithm. So by the algorithm works like this. When a query arrives, the search engine allocated to the bidder I that maximize the multiplication of the bid price BI times phi of x, where phi of x is 1 minus EX minus 1, and x is a fraction of bidder I's budget that has been spent so far. So, and this algorithm achieves the optimal competitive ratio of 1 minus 1 over E. And then they can extend the competitive ratio result to the realistic case where multiple ads can appear with the result of a query, and the bidder pays only if the users click on its advertisement, and the bidders have different budgets, and also the case that instead of charging a bidder its actual bid, search engine charges to the next highest bid, so the second highest price. All right, so with those preparation, we can introduce the short video advertising industry. So as I believe that you are aware that in the last several years, TikTok is emerging, and it has gained over 1 billion users in over 150 countries. It becomes the top-rated app in the world. And it is expected to reach 1.5 billion monthly active users by the end of 2022. And this is another figure to showcase that TikTok is ranking #1 globally for ad equity, and the revenue is going to reach 11 billion in 2022. So why short videos is so attractive? It's because of the engagement with influencers. So on the short video on TikTok and some other short video platforms, there's another category of users, which we call influencers. So they make interesting short videos and attract followers. The more followers that they have, the more likely that advertisers will try and find those influencers and pay them to advertise the product. So on the short video on advertising platform like TikTok, instead of the apart from the short video platform, like the traditional search engine platform and the advertisers, we also have a new set of agents, which is the set of influencers. The advertisers, instead of owning buying advertisement from the platform, they can also make advertisement together with influencers and pay to the influencers to display the advertisement. So, one challenge in figuring out the best pricing for the best payment to the influencers is to estimate the user traffic bonus for the influencers, because the more followers and the more number of video displays that the influencer can achieve, the more payment that the advertisers are willing to pay. So in our work, we use badges we design badges to gear influencers' incentives and hence make a significant contribution to the booming of our platform. Those badges balance the influencers' influence and the display time. So here is the problem formulation. We have a set of advertisers. Each advertiser I has a fixed daily budget, and the platform has a set of AdWords slots, each slot representing a short period of time, and each advertiser I submit its bid price BIJ for slot J and the budget constraint capital BI to the platform, as well as the traffic bonus value RI if published by the influencers. When receiving those inputs, the platform must immediately allocate each slot J to an advertiser I style. And the platform is interested in maximizing the revenue collected from the advertisers and the users' traffic generated by displaying the influencer ads. So here we display, here we designed an ad slot allocation algorithm that is based on a linear programming modeling. And we have our competitive ratio analysis. And the competitive ratio is also 1 - 1 over E, which is tight. We evaluate our work on a data set. We construct a short video playback data set generated from ICME challenge. And we compare it with 4 baseline algorithms: budget constraint, bid price first, traffic boundaries first, and virtual boundaries. So from the experimental result, we observed that our proposed algorithm outperforms others, and algorithms take traffic boundaries into consideration should be better. And also from this figure, we can see that our proposed algorithm encourages to display of advertisers' ads, and more revenue is gained with more influencers' ads. So this is encouraging the influencers to improve their short video, and attract more followers to boom the industry, to boom the platform, and also attract the advertisers' investment. So that's all. Thanks for your attention.